Welcome back to Explaining Everything, the channel where we dive into the stories and mysteries behind everyday things. Today's question comes from one of our curious viewers, Carter Flies 35. Thanks for the suggestion, Carter. You asked, why are rubber bands so stretchy? If you've ever been baffled by how a tiny loop of rubber can stretch across the room, or why it sometimes snaps at the worst possible moment, then you're not alone. There's a whole lot of science packed into those stretchy little loops, and today we're unraveling it all. So, if you've ever launched a paperclip at a friend, or just wondered what makes rubber bands elastic in the first place, stick around. We're breaking it all down right here on Explaining Everything. Let's start with the source of rubber itself. Most rubber used in rubber bands comes from the sap of rubber trees, primarily grown in tropical regions like Southeast Asia. This sap, called latex, is a milky liquid loaded with long, stringy molecules known as polymers. Think of polymers as molecular spaghetti, long, tangled, and ready to stick to everything. When latex is harvested, it's processed to create natural rubber. But here's the catch. Fresh latex is kind of a flop. It's sticky, weak, and not nearly stretchy enough for rubber bands. That's where a bit of science wizardry called vulcanization comes in. In the mid-1800s, Charles Goodyear, yes, like the tire company, accidentally discovered vulcanization. Picture this. He's messing around with rubber and sulfur when he accidentally drops the mixture onto a hot stove. Instead of turning into a useless mess, the rubber becomes stronger, more elastic, and heat-resistant. Goodyear probably thought, I am a genius, and honestly, he wasn't wrong. So, what is vulcanization? It's a chemical process that adds sulfur to rubber and heats it up. The sulfur creates cross-links between the spaghetti-like polymer strands, turning them from a sticky glob into a stretchy, durable material. This is why rubber bands can stretch to ridiculous lengths without snapping, most of the time. Here's where it gets really fun. Rubber's elasticity comes down to the behavior of its polymers. In a relaxed state, the polymers are all tangled up, like headphones you left in your pocket overnight. But when you stretch a rubber band, those polymers straighten out and line up like a neat row of soldiers. Let go, and they snap back to their original tangled chaos. But wait, why does this happen? It's all about entropy, a fancy physics term that basically means things prefer being messy. Polymers love their tangled state because it's higher in entropy. When you stretch a rubber band, you're forcing the polymers into an unnatural order. The moment you release, they rush back to their comfy, chaotic tangle. It's like a molecular version of crashing on the couch after a long day. Now, here's a plot twist. Temperature can mess with rubber's elasticity. Ever noticed how a rubber band feels stiffer in winter? That's because low temperatures make the polymers less mobile, so they don't stretch as easily. On the flip side, if you heat a rubber band, it becomes more elastic, but also weirdly shrinks when stretched. Physics is like that friend who always does the opposite of what you expect. Not all rubber bands are made equal. While many are made from natural rubber, some are crafted from synthetic materials like silicone or nitrile rubber. These bands are less biodegradable, but more resistant to extreme temperatures and chemicals. If you're using a rubber band to hold together your space exploration kit, you'll probably want a synthetic one for, obvious reasons. Let's talk about heartbreak, specifically the heartbreak of a snapping rubber band. Over time, rubber degrades due to exposure to oxygen, UV light, and repeated stretching. This process, called oxidative degradation, breaks down those precious polymer crosslinks, leaving the rubber brittle and prone to snapping. If your rubber bands are constantly breaking, it might be time to invest in a fresh batch. Or better yet, store them in a cool, dark place to prolong their lifespan. Just don't refrigerate them unless you're ready to explain to your roommates why your fridge has a dedicated rubber band drawer. To wrap things up, here are a few rubber band facts to blow your mind. First, the world's largest rubber band ball weighs over 9,000 pounds and was made with more than 700,000 bands. That's a lot of potential for a massive snap. Second, NASA uses rubber bands in some spacecraft to absorb vibrations. Even astronauts need a bit of elasticity in their lives. Third, rubber bands can store energy when stretched, a principle used in DIY slingshots and science fair experiments everywhere. So, next time you grab a rubber band to organize your desk, bundle your veggies, or launch a paper projectile at a coworker, we won't judge. Take a moment to appreciate the wild mix of chemistry, physics, and history that went into making it so elastic. It's not just a simple loop of rubber, it's a molecular marvel. If you enjoyed this deep dive into the stretchiness of rubber bands, don't forget to like, subscribe, and hit the notification bell. Also, if you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for tuning in, and join us next time here in the channel that answers all the why, what, who, where, and how questions you've always wondered about. Here on Explaining Everything.